Hello! Welcome to Mary's Pure Math lesson. Today I am going to tell you how to solve question number 5. Well, let's read the question first. The function f is such that fx equals to 2x plus 3 for x is greater than and equal to 0. The function g is such that gx equals to ax squared plus b for x is less than and equal to q, where a, b, and q are constants. The function fg is such that fgx equals to 6x squared minus 21 for x is less than and equal to q. Number 1. Find the values of a and b. Let's see. If we want to find the values for a and b, we'll definitely be needing fgx. Well, fgx means that the function g acts on x first, then f acts on the result. So let's see how they turn into 6x squared minus 21. fgx equals to f parentheses ax squared plus b. So you see, g acts on x first, and now we need to make f act on the result. So then it would be 2 times the sum of ax squared plus b, then plus 3. And it will be 2ax squared plus 2b plus 3. Since fgx equals to 6x squared minus 12, then we can see that there's only one x squared in this function fgx we just solved. Then we'll know that 2a is equal to 6, and therefore a would be 3. And this part will be equal to negative 21. So 2b would be negative 21 minus 3, which is negative 24. And therefore b would be negative 12. And we already learned that a is 3 and b is negative 12. Then in this question we'll probably use this. So question number 2 asks us to find the greatest possible value of q. And we already learned that fx domain is x is greater than or equal to 0. So from fgx, we can tell that in this composite function, gx is greater than and equal to 0. So 3x squared minus 12. This is the function for gx. This is greater than and equal to 0. We can solve this by dividing each side by 3. Then we will have x squared minus 4 is greater than and equal to 0. So x squared is greater than and equal to 4. And now since this is a squared x, then we will have to find out the 2 values of x. And let's just draw a graph of the function for gx. Well, because the constant of the function is negative 12, so when x is equals to 0, we'll know that y, the coordinate of y would be negative 12. And if we put 4 under a square root sign, then it could be either negative 2 or 2, because the square of negative 2 is root 4, and the square of 2 is also root 4. So this is negative 2, and over here is 2, because we know that a function is y equals to ax squared plus bx plus c. So when this part is not present, then the symmetric line would be x equals to 0, which is on the line of y-axis. So then we will have a graph looking like this. Yeah. And so when x squared is greater than or equal to 4, we will know that it's pretty much the part over here. Then we'll know that x is whether greater than or equal to 2 or x is less than and equal to negative 2. And since x in the function of gx, the domain is x is less than or equal to q. So then the greatest possible value of q would be negative 2. It's given that q is equal to negative 3. Question number 3. Find the range of fg. It is already given that in the function fgx, x is less than and equal to q, and it is already given that q is negative 3, then we can see that x is less than and equal to negative 3. Then we can bring x equal to negative 3 into the function fgx. Then we would have 6 times the square of negative 3 minus 21. And it would be 6 times 9 minus 21, which equals to 33. And how do we determine if fg is greater than and equal to 33 or fg is less than and equal to 33? Well, we can draw our graph. So, as you can see that this is negative 21. So when the coordinate of x is 0, the coordinate of y would be negative 21. And this is also the symmetric axis of this function. So since we know that x is less than and equal to negative 3, then let's assume this part is negative 3, and we would have a function like this. So as you can see, when x is decreasing, the value of y is increasing. So therefore, we will know that fg is greater than or equal to 33. Now finally, the last one, question number 4. It asks us to find an expression for the inverse function of fgx and state the domain of the inverse function of fgx. Then first, let's copy down the function of fgx. let's turn the thing into y, so when we write it, it is more simple. Then we could express this as y equals to 6x squared minus 21. And now, in order to find the inverse function of f g x, we need to make this y is actually the x of the inverse function of f g x. So then it would be x equal to 6. It would be x is equal to 6y squared minus 21. Now let's get x on this side and y on this side. So we first bring negative 21 to the other side. It will be x plus 21 equals to 6y squared. Now we divide this by 6. So divide both sides by 3. X plus 21 divided by 6 equals to y squared. And now since y is squared, then this is actually kind of hard, but not that hard. So y could be root x plus 21 divided by 6, or y is equal to negative root x plus 21 divided by 6. Then how do we know that which is the correct answer? Well, since q is given that it's negative 3, then we can see that this is obviously not correct. So we can cross that out, and therefore the inverse function of f g x would be negative root x plus 21 divided by 6. And now we already find the expression for the inverse function of f g x, then we can find the domain of the inverse function of f g x. And since the range of f g x is that f g is greater than or equal to 33. We got that from this question, remember? And since that's the inverse function, then the domain of the inverse function of f g x is x is greater than and equal to 33. At last, thank you for watching. I hope you enjoyed my math lesson. I hope you all the best and health.